Today I'd like to tell you about an experiment that you as a young immunologist can do in your lab that will provide a surprising result for your supervisor. There are molecules that were reported to exist in the 1970s called specific T cell factors. Specific T cell factors have a controversial history. They were very exciting molecules back in the 70s because they seemed to be playing a key role in the regulation of the immune system. But they went out of fashion, and there are a couple of reasons for that. The reasons don't matter too much at this stage. What does matter is that there is a very simple way of determining whether these factors exist or whether they don't exist. Specific T cell factors are part of the symmetrical immune network theory that has been developed over the last 40 years and is currently leading to new important biotechnologies. At Network Immunology, we are doing experiments where, based on that theory, we can demonstrate significant enhancement of graft survival in mice. We have every reason to believe that this same technology can be used in the prevention of degenerative diseases, including autoimmunity and cancers. So we're making some big claims here. It's all based on a theory that is in turn based on specific T cell factors. And the one thing that is unclear for most people, most immunologists, is whether the whole thing is built on sand, because it's based on specific T cell factors that for them have become history, or whether or not those things actually exist. If they do exist, then most immunologists and billions of dollars of research funds are being devoted to the framework in which they don't exist, and that framework is wrong. For just a few mice and the cost of a few reagents in the lab, you can find out for yourself whether specific T cell factors exist and have been overlooked and dismissed, or whether they actually do exist. It's an important question. And you, as a young immunologist, can easily do the experiment. You can look up the paper, Takamori and Tada, 1975, and it's a rigorous experiment with what I call crisscross specificity controls, 90% suppression induced by these factors, 90% suppression of the IgG response. You can determine whether those factors with those properties exist or not. If you find that they do exist, and you show the results to your supervisor, then you have to ask the supervisor, why are we neglecting this? You will also be one step ahead of people who, by just reading current textbooks, think that these factors don't exist. I started off in theoretical biology with doing my PhD in the Max Planck Institute for Biophysical Chemistry, where Manfred Eigen was a director. He'd won a Nobel Prize for his work on very fast reactions, and my job for my PhD was to build a piece of equipment that measured reactions that took place in less than a microsecond. While I learned a little about instrumentation for that project, the main thing I learned while I was a student there was that theoretical biology was a fascinating field. Eigen had moved from being focused mainly on fast reactions to being interested mainly on theoretical biology, with many different parts of theoretical biology. We had many visitors coming through the institute interested in different parts of theoretical biology. And So I was a very attentive listener to all of those lectures, including lectures on the origin of life, which was the area where Eigen himself was doing his best to make his contribution to the field. From that experience, I was able to write a paper myself on the origin of life, and that got me into the world of theoretical biology, and it also led to me hearing a lecture by Niels Jerne in January of 1974, where he talked about the immune system being a network. He talked about the immune system consisting of cells called lymphocytes, immune system cells, and antibodies that not only recognized things that were foreign to the immune system, but they also recognized each other and responded to each other in some sort of a dynamic way, which he envisaged to be similar to the brain. He knew that the brain is a network, and he said, well, here we've got components that can recognize each other. Maybe the immune system is also a network very much like the brain, and that analogy partly inspired him to think along those lines. At the end of 74, I joined Jerne at the Basel Institute for Immunology and had some discussions with him, and he mentioned a couple of phenomena to me that he said, so-and-so has this molecule called a specific T-cell factor. That doesn't make any sense, does it? Jerne himself was very much interested in antibodies. For him, the antibodies of the immune system were really the important molecules, and he wasn't very happy hearing about molecules that had specificity being made by T cells. In other words, they had V regions, they had what are called variable regions that are capable of recognizing other variable regions or capable of recognizing things that are foreign. He wasn't enthusiastic about that particular type of molecule. There's also another phenomenon that he drew to my attention that he was more interested in, or more convinced of its possible significance. Anyway, using both of those findings, I went away and I'd already been doing some work on this when I was in Göttingen, but I could see what some of the problems were in putting together a network theory. In fact, I interacted closely with a physicist in Göttingen called Peter Richter, and he had the first version of network theory that were based on Jerne's ideas. And I'd learned a lot from seeing how Peter addressed the problem. And so together with the experience of having interacted with Peter Richter and then these facts that Niels Jerne was telling me about, I went away and I found a way of putting the pieces together that seemed to do some of the right things. First of all, it had stability. It didn't sort of oscillate all over the place, which was what the problem was having when I was trying to address it in Göttingen. And had stability, so there was a potential for memory there by having the needed stability and the needed ability to switch between different stable states of the system. If you're going to have memory, if you're going to be able to learn, you have to switch from one stable state to another stable state. I found a way of putting the pieces together that seemed to be doing some of that, and I wrote up a paper and I published it as a single author paper. That single author aspect of it was a blunder. Jerne had contributed to it by drawing my attention to these two phenomena that I mentioned, and he should have been included as a co-author. That came back to bite me because Jerne was the grand old man of the field. He was Mr. Immune Network Theory. I was a young whippersnapper. I didn't have a network of scientists that were connected to me the same way that Jerne did. And sure enough, in 1984, a few years later, Um, Yarner was awarded the Nobel Prize for his immune network theory, or it was really a hypothesis. He wouldn't have got that Nobel Prize if it hadn't been for the fact that lurking in the background, there was a version of immune network theory that I'd put together that made sense, that I'd put together with his assistance. There was a period of recognition of immune network theory. However, that recognition turned out to be short-lived because it wasn't coupled to the exact details of the theory that had come together. And as a result, I had not been as generous as I should have been towards Yarner, and with me being just a young whippersnapper without a network of supporting scientists in that area, it simply became something that was on the shelf and people didn't feel they needed to worry about it too much. If you are a young scientist and you want to know how you can contribute to this field, the first thing you need to do is find out whether specific T cell factors exist or not. It is a question as basic as the question in physical chemistry of whether the neutron exists or not. It's an experiment that costs a few dollars and a few mice. You can ask your supervisor for permission, but even smarter, he's not going to notice you having a few mice doing this experiment, because if you ask him, he's likely to say, no, don't waste your time on that. That's a distraction. And it's been known for years and years and years that specific T cell factors don't exist. You need to find out for yourself. When you've got the result, go to him and say, oh, look what I found. This is a way that you can contribute. You can contribute to the field moving forward. And the field has some catching up to do. At Network Immunology, we're developing science technologies based on it. They're working. If specific T cell factors didn't exist, our technologies wouldn't be working. We know that they exist because the technologies are working. But you can catch up by, first of all, finding out for yourself whether antigen-specific and anti-idiotypic T cell factors exist or not. Thank you.